So hello students, welcome back to my channel again. So this is the lecture number 3 of the mechanical properties of solids. This is the topic is stress versus strain graph of a metallic wire. Especially for the ductile material we will discuss today, right? So as we know already, the stress means the force upon area and the strain means the change in length by original length, right? So that means stress means force upon area and the strain which is nothing but change in length, I mean change of any dimension. Dimension means change of volume by original volume, that can be also a strain also, right? So and we also know that stress and strain is proportional up to a certain limit, right? Now let me show you how to draw the graph. So first of all, I will take the graph. Stress is in x-axis, sorry, the stress is in y-axis. I will take this, and the strain in this x-axis, right? So this is the first, you will take the stress in y-axis and the strain in x-axis. Now how the graph will be looks like. So first of all, stress proportional to strain up to a certain limit, I mean where if we remove the proportional sign, one constant will come, constant into strain, and that constant is nothing but stress upon strain. And you can see here stress upon strain. Stress is in y-axis, so I can write delta y, and strain is in x-axis, so that means I can take as delta x. And as we know, delta y by delta x is nothing but slope or tan theta. All right, it is also called slope. So that means what does this slope define? This slope define nothing but the modulus of elasticity, the modulus of elasticity, right? So this is, now let me show you first thing. So let assume a point up to a point A. From this origin we are applying stress and corresponding strain we are just taking, right? So we are drawing a graph like this, stress versus strain graph, and you can see up to a limit, this limit up to a point A, it is proportional. Stress and strain are proportional, means how the stress is increases, I mean stress means I am applying force on the wire, due to that the strain is also increasing, I mean there is a change of length is also happening, right? So due to the application of force, the change of length happens, and this is directly proportional. What does it mean? So if we take a graph for an example, you can understand. For example, initially I am giving a stress of 1 Pascal. Stress unit is, we know, Newton per meter square or Pascal. So 1 Pascal strain के लिए, for example, stress के लिए, for example, the strain is 2. Strain does not have any unit. So now if we increase the stress into 2 Pascal, let the strain becomes 4. Now if we increase 3 Pascal, it becomes 2, 4, 6. Now for 4 Pascals, let assume this is 8, and from 5 Pascals, let assume it is becomes 10. So if you can understand, whenever I am increasing the stress, the strain is also increasing. That means the gap, individual gap is also same. That means they are constant straight line graph. So this part is a linear graph and this part is a linear graph. Okay? And this point up to a particular point, these properties will maintain, and that particular point name is called proportional limit. This is known as proportional limit, where proportionality will maintain. That is known as proportional limit or limit of proportionality. Okay. Now next topic is next thing is, after point A, what will happen? So as I said, when you are applying force on a wire, the wire will increases. This is the increase in length, delta L. डेल्टा एल, ठीक है। चलो अभी इसको डिक्रीज करेंगे 5 पास्कल से, जब when we will do the 4 pascal again, means if we will decrease the force, so what will happen, this 10 will become the 8 again. Are you getting my point? Now when we make it 3 pascal, it becomes 6. When we make it 2 pascal, I mean initially we gradually increases the stress, thus it is also increasing, and now we are decreasing the stress, we can see it is also decreasing. What does it mean? That means till point A, means the rate of increase, or you can say the rate of decrease for stress and strain are same. That's why the graph is a straight line graph. Okay, now after point A what will happen, let me show you. Let's assume after point A the graph will no more a straight line, it becomes a curved line. So graph will be like this, this will become a curved line after point, this is the B. So I will write down one by one. Here OA is the proportional limit, proportional, I mean stress and strain are proportional, that's why it is a straight line. After point A, from A to B, it's not a straight line, but there is a condition that when we remove, suppose I am pulling a wire and when I am removing the force, the wire is bounced back to its original shape again. For example, let's assume I am taking a wire of 1 meter length, ठीक है। Now I am applying force, this is the force I am applying, pulling it, so its length has been increased to 1.1 meter, then again it bounce back. When we remove, after removal of the deforming force, it bounce back to its original shape again. This is called elasticity actually. So up to point B, this elasticity will maintain. So up to point A, proportionality maintain. Proportional means graph will be straight line. जैसे स्ट्रेस इंक्रीज होगा स्ट्रेन भी वैसे ही इंक्रीज होगा, जैसे स्ट्रेस डिक्रीज होगा स्ट्रेन भी वैसे ही डिक्रीज होगा. दैट मीन्स perfectly straight line graph you will get till point A. But after point A, the graph is not a straight line, but elasticity will maintain. Remember, proportionality will not maintain, but elasticity will maintain. What does it mean, elasticity? That means when we increase the length by applying force, when we remove the force, it will bounce back or it will regain its original length, original shape. That is called elasticity, and this will maintain up to point B. So that's why this point B, the corresponding stress of point B, this point B is known as elastic limit. Elastic limit, this point B is called. And the strength at point B is denoted as SY. That means that's the yield point or elastic limit, or it is sometimes is also called yield point. So till yield point, the properties of elasticity will maintain, right? Now at point B, what is the stress? That is SY. That stress at yield point or stress at elastic limit, at elastic point, is nothing but is known as yield strength. Yield strength. Okay, so it is called yield strength. Now so up to point B, wherever there are lots of points are there, wherever if you remove the deforming force, the wire will get back to its original shape again. That means the wire will bounce back through this path BAO. That means from O to B, that is known as elastic region. O to B is known as elastic region. Means after removal of deforming force between any point of O and B, कोई भी एक पॉइंट में if you remove the deforming force, it will come back, it will regain its shape again, it will regain its shape again. It will means the wire will regain its shape again up to point B. Now what will happen after point B? Let me show you the after point B. Now next thing, after point B, what will happen after point B? The small stress or small force can change a large increase of strain. Actually, that means the stress is very small after point B. Stress is small, but the strain, that means the change of dimension, is very large. That means the concept of thinning process started. Thinning means when you are pulling a wire, you can see the wire is gradually, the diameter of the wire is decreases. That means it becomes thinner, very thin wire it forming. Actually, that is thing happen after point B. So after point B, the graph will be like this. Actually, it will be moving and reaches a maximum stress, and then after sometimes it breaks. So I'll take the point, another point, any arbitrary point C over here. So C point में क्या होगा? So after point B, and this is D, and I am taking as this is E, and now up B to D, this region, B to D, this region is known as plastic region. What does it mean by plastic region? Plastic region का मतलब होता है when we are applying force and when we are removing the deforming force, it will not bounce back to its original shape, and it will be continuously increasing its length. Continuously, there will be, even without applying any force, the length is continuously increases. That is known as plastic region, or also called plastic flow. So what will happen at point C? C is any arbitrary point between point D and point B. Between B and D, I am just taking any arbitrary point, that is point C. So what will happen? क्योंकि C point elastic limit के बाहर है, so what will happen? When we remove the deforming force, original 1 meter length, it will never regain. क्या होगा? There will be a permanent change will happen. Let's assume the initial length of the wire was 1 meter. Now if we apply a force more than elastic limit, then what will happen? There is a permanent change of the wire will have permanent change, or there is a permanent strain happens. Means even without any stress, the strain is not zero. Strain is not zero. That means a residual strain has been arises. That means elastic hysteresis will be arises. Now let me show you. This is, that means it will not come back to the original point O. It will never come back again. Rather, it will come back to some other point which is just parallel to this. Another point, let's assume this is F. This OF, that means there is a permanent shift happened. What is the length of the wire? Initially was 1 meter. Now the length of the wire become permanently 1.2 meter. Even I am not applying any force, the wire length becomes 1.2. That means there is a permanent change happens due to the, when we cross the elastic limit. When we cross the elastic limit, this will happen, right? So this is known as permanent set. Permanent set. ठीक है? Now this will set known as permanent set. That means the strain is not zero. That means the strain is not equals to zero after point B. That means there is a residual strain is there. There is a residual strain is there. Residual means when we remove the stress to be zero, the strain is not zero. Some extra strain is still there. This region OF, permanent change happened. Some extra means initial length was 1 meter. Now after crossing the elastic limit, the length becomes 1.2 meter. Even after my application of force is zero, I am not applying any force. Still, the body becomes a permanent change happens 0.2 meter. Right? That is known as the permanent set, or it is also called residual strain. Strain means what I said, delta L by L. So that means delta L, change of length, permanently there is a change of length happens, which is also called elastic hysteresis. Elastic hysteresis. That means there is a elastic hysteresis will happen. That means जो पाथ से गया था उसी पाथ से वापस आना था, लेकिन it is not coming back after the point B. It is not coming back through this point. It is coming back some other point. That is the called hysteresis actually. ठीक है. So after point, so B से D तक A region, इसको बोलते हैं प्लास्टिक फ्लो, जिसमें क्या होता है, even after I am not applying any force, the length is continuously increasing. So the D जहाँ पे मैक्सिमम स्ट्रेस होगा, वहाँ पे जो मैक्सिमम स्ट्रेस एट पॉइंट D जहाँ पे that is known as ultimate strength. So here SU is known as ultimate stress. अल्टीमेट स्ट्रेस, उसका फ्यूचर वहीं पे डिसाइड हो गया, अभी वो टूटने वाला है. ठीक है. सो डी के बाद ही वो क्या होगा, टूट जाएगा. दिस ई पॉइंट एक्चुअली मीन्स दिस टू आर वेरी क्लोज एक्चुअली, डी एंड ई. तो इसमें क्या होगा, द स्ट्रेस देखो, स्ट्रेन इज कंटिन्यूअसली इंक्रीजिंग. दिस इज द स्ट्रेन जोन एंड दिस इज द स्ट्रेस जोन. स्ट्रेस इज वेरी स्मॉल. So there is a small change of stress, but the strain is continuously increasing, and finally it fractures and breaks into two parts. Means we are applying too much of force, a wire broken into two parts. That is E point is known as fracture point, E point or rupture point. So E point is known as fracture point or rupture point, where the total length of the wire is broken into two pieces or maybe more than two pieces. So this is happening stress versus strain graph for a metallic wire. Especially this is for a ductile material. Ductile means which can be increased, I mean by applying force we can increase the length of the wire. That is ductile material. And for a brittle material, what will happen for brittle material? I am just writing here. For a brittle material, you can see stress versus strain graph. The elastic limit or fracture point बहुत close है. That means the plastic zone is almost negligible in case of brittle. Means we are increasing the length of a brittle material just more than elastic limit, it will be broken. For example, a glass. Glass is a perfect example of a brittle material. Means if you are trying to put more forces on it, it will be broken into pieces. That means that is called, that means where the elastic and fracture point are very close, that means plastic zone almost negligible होता है in case of brittle material. In case of ductile material, elastic zone and the plastic zone is very large, or you can say elastic point and the fracture point are very far away from each other. So this is the overall scenario of stress versus strain curve of a metallic wire. So एक एक चीज पे ध्यान देना. O to A, that is proportional, that's why straight line. A to B is not proportional, but still it is maintaining elasticity will maintain. Means if we remove the deforming force, it will regain its shape. Means उसी पाथ से वापस O में आ जाएगा, लेकिन B के बाद वो फिर O में वापस नहीं आएगा, वो कोई दूसरे पॉइंट पे आ जाएगा. दैट इज देयर इज ए परमानेंट चेंज हैपन ऑफ द वायर. डेल्टा एल हैज बीन परमानेंटली चेंज्ड. जो 1 मीटर का वायर था वो 1.1 मीटर 1.2 मीटर हो जाएगा. मतलब देयर इज ए 0.2 मीटर का एक्स्ट्रा एक्सटेंशन आ गया, इलोंगेशन आ गया, राइट. सो दिस विल हैपन बेसिकली, एंड फ्रॉम B to D दिस रीजन इज नोन एज प्लास्टिक रीजन. प्लास्टिक जोन में क्या होता है, इलास्टिसिटी धीरे धीरे खत्म होने लगता है, एंड द वायर बिकम्स वेरी थिन. Wire, the diameter of the wire becomes very narrow wire it forms, right. So what will happen, so from B to D plastic zone. Plastic zone का मतलब क्या होता है, even after I am removing the force the length is continuously increasing. यही होता है प्लास्टिक जोन. इलास्टिक जोन में क्या होता है, when we are removing the force it will come back to its original shape, but in the plastic zone it will never come back to its original shape. It will continuously increasing its length, and it is the maximum stress. जो maximum stress जो wire को मतलब it can tolerable limit, maximum tolerable limit. After that it will be broken into pieces. So this is the broken point or fracture point it is also called. So this is all about the stress versus strain graph of a metallic wire. So thank you, that's all for today.